Hi everyone. In last class we have discussed regarding step response of a second order system and lag compensation. So lag compensation, same procedure is followed for lead compensation and also for the lag lead compensation. Okay. Today we shall discuss regarding the characteristics of AC servo motor. So how to take these readings and all I will explain. Okay. So procedure I will explain. So here the circuit diagram is like this. So here it is a main switch and here there will be a knob to vary the control voltage, and here there will be a display. It will in speed it will show. So when you switch on the power, okay, first we will switch on the power. So 1 I will write. Next you will switch on the motor, that is 2, and next you will vary the control voltage. Okay. So by varying the control voltage, what you will note down? So back EMF you will note down for the first table. Okay. So the first table will be like this: back EMF and speed. Okay. So the first table will be like this: back EMF and the speed. Okay, you can observe. So back EMF and the speed. So how to set a speed means by varying the control voltage. Okay, by varying control voltage knob, the speed will be displayed, and here the multimeter need to be connected. Here multimeter, okay, we use multimeter. So that too in DC, because back EMF is DC. Okay, so you need to set in a DC multimeter. When you consider the multimeter across the back EMF, here one connection will be there, here one connection will be there. So one will be common terminal to the multimeter, one will be the voltage terminal, one will be connected to the voltage terminal of the multimeter. Okay, so two terminals we will connect across EB, that is back EMF. Okay, so that too we will keep the multimeter in a DC. Okay. So by varying the speed we will take the value of back EMF, that is the tabular column 1. Next for that you need to draw the model graph back EMF versus speed. Okay. Next tabular column. So here the control voltage we need to set, that is VC1 equals to 45. Here I have considered. You can consider the voltage 190 voltage, 210 voltage, 220 voltage, like that. Okay, that is control voltage, control winding voltage. So here the table is like this: IA, okay, current, speed, back EMF, power. Okay, and torque you need to calculate, that is the formula torque equals to P into 1.019 into 10 to the power 4 into 60 divided by 2 pi n. Okay, so you need to calculate the torque and you need to calculate the power also. Power equals to what? 2 pi nt divided by 60. So how you will calculate how you will take the second reading, second tabular column means, first control winding means this is the control winding, two connections will be there, 1, 2. One is common and the second one is voltage, and here the multimeter should be in AC. Okay, the multimeter should be in AC. So you keep some voltage. For example, I have kept for 140 voltage across control winding. Okay, this is reference winding and this is the control winding. Okay, so we have kept the 140 voltage, we shall think. Okay, so how you will keep the 140 voltage? By varying the control voltage. So you need to switch on the servo motor. Don't check the speed, just you vary the control voltage until you get the 140 voltage in the multimeter. That too you need to keep in a AC. Okay, so when you get the 140 voltage, stop this control voltage. Okay, so no need to vary the control voltage after getting the 140. Again, don't vary that knob. Okay, control voltage. So here the current will show, here the current display will be there. You can observe here amps is there, and here the RPM, that is speed unit. Okay, so next, after setting the voltage across 140, okay, next servo motor will be on, control voltage will be, don't vary this control voltage knob. Okay, switch on this load. Okay, switch on the load, and multimeter connection should be connected here. Okay, multimeter connection, and that too in DC. Okay, one connection is for voltage, one is common. Okay, and load should be on, vary this load. Okay, vary this load, vary this load, note down the speed and note down the current. Okay, by varying the load you need to note down the speed and the current. So load, okay, switch on the load, and multimeter connection should be connected here. Okay, multimeter connection, and that too in DC. Okay, one connection is for voltage, one is common. Okay, and load should be on, vary this load. Okay, vary this load, vary this load, note down the speed and note down the current. Okay, by varying the load you need to note down the speed and the current. So here we are varying the current value only. Okay, when you increase the when you apply the load, that means we are increasing the value of current. Okay, here, so the current value will be increased. For example, if it is showing starting only 0.5, then you consider 0.51 or 0.55, 0.56, or you can consider 0.51 to till 0.6. Okay, you can take 10 readings and it will be helpful for graph. Okay, so that is the second tabular column. So first you need to what? You need to switch on this main supply, control voltage. Okay, by varying this control voltage you need to set a 140 voltage across the control winding here. Okay, you need to set voltage 140 or 210, 190, like that. Okay, how much you set that voltage you need to write, that is. Okay, after setting this control voltage winding, next you need to switch on this load. Until that you should not switch on the load, only you should switch on the servo motor. Okay, after setting voltage, next you connect the multimeter to back EMF and vary this load and note down the speed and also the ammeter, that is current. Okay, when you vary the load, the current value will be changed. Okay, for example, if it is starting 0.5 is there, then it will vary when you vary this knob. Okay, load knob, so 0.51, it will increase when you vary the load. Okay, according to that you need to note down the RPM value, back EMF value, and later you need to calculate the power and torque, and next you need to draw the graph for that. Okay, this is the graph, torque versus speed. So in next class we shall discuss with the other experiments.